Everyone. Today I will show you about the way to find about the diagonalization of the matrix 3 by 3. Uh, so when we want to find about the diagonalization of the matrix 3 by 3, the first we should find about uh, the first we find the eigenvalue. The first we talk about eigenvalue. Eigenvalue. So we find about lambda, the value of lambda. The second, we find about the eigenvector. Eigenvector, we got V, Vi. And the third, we find about modal matrix. Modal matrix is matrix P equal to Vi, or we can write V1, V2, V3, blah blah blah. And the fourth, the diagonalization of the matrix A is equal to the inverse of modal matrix multiplied by A and multiplied with modal matrix. So now I find the first. I find the eigenvalue. This one, value. Eigenvalue. So depend on to this matrix is 3 by 3. Is 3 by 3. So we find about the characteristic equation. I call characteristic equation. Characteristic equation is I can write lambda cube. This is the cubic equation. So this one is minus because in determinant is plus, minus, plus, minus, plus, minus, and point. We change from plus minus, plus minus. This is, I told you already why it is minus, why it is plus. So D, I just write in D lambda square and plus C lambda minus determinant of A equal to 0. So D is diagonal matrix. Diagonal matrix of A and D is sum of diagonal value. So D is equal to sum of the diagonal, this one. I can write sum of this one there. So I can write 5, 1 minus 5 plus 4 equal to 0. And the next we find about the C. C in this one is cofactor of matrix A of matrix C. C is equal to C11 plus C22 plus C33. So C11 C11 it means we omit this one, and we omit this one. Okay, omit this one and this one. We got, or I just write, I omit this one and this one. So we got C11 is equal to, so I got C is equal to, this one is 20 minus 20 and plus 18. So is minus 2. And then C22. It means that I just omit this one and I omit this one. So I get 4 minus 18. 4 minus 18 is minus 14. And the next I want to C33 this one and omit this one. So we got 5 plus 9. 5 plus 9 is 4. So it's plus 4. It's equal to minus 12. This one, C equal to minus 12. And now we find the determinant of A. Determinant of A. Determinant of A is equal to, this one I can omit this one. And this one. So 20 minus plus 18 is minus 2, equal to minus 2. And I omit this one and this one. 12 minus 18. 12 minus 18 is 16. 12 minus 18 is 6. 6 multiplied with 3 is 18. This one is minus 18. And this one is 3. Omit this one and this one. 30 minus 30. Minus 30 minus 18 plus 30 is plus 12. So we got this one is this one 12 and 12 multiplied by 3. 12 multiplied by 3 is 36. So I got this one is 36. This one is 36. And when we got this one is 36, we just to write the characteristic. So I write lambda cube minus d. D is 0. Lambda square plus plus, so plus and minus is minus 12. Lambda minus and plus is minus 16 equal to 0. Equal to 0. So we got this equation is lambda cube minus 12 lambda plus 16 equal to 0. But this one has root, has minus 2 is basic root. Basic root. Because when we use minus 2 power 3 plus 12 minus 2 minus 16 is equal to 0. It's true. It's true. So I can write this one is the factorize. Factorize, I write plus 2. And that's one we just to take this one. We got about the lambda cube or lambda square, this one. And the next is 18. 18, it means minus 18, minus 16, sorry, is equal to 2 multiplied by minus 8. Minus 8 is minus 12, 8 and 12. So is minus 4. So I can write or something we can just to take canonic. We got we do with the canonic. We take lambda cube minus 12 lambda minus 16 to be with lambda plus 2. So we write this one is lambda square is minus lambda cube minus this one is 2 lambda square. So we got this one is minus 2 lambda square minus 12 lambda minus 16. So I get 2 lambda minus 2 lambda. And minus 2 lambda is this one 2 lambda square. Minus 4 is plus 4. Lambda is minus 8 lambda minus 16. So I got minus 8. Minus 8 here. So minus 8 here is this one we got minus 2 lambda and minus 8 equal to 0. But 2 minus 2 is like 4 plus minus 2. This one is 4 multiplied by minus 2. So we got this equation we can write plus 2 and this one lambda plus 2 and lambda minus 4 equal to 0. So we got lambda plus 2 square, lambda minus 4 equal to 0. Now eigenvalue of matrix A is lambda equal to minus 2 and 4. So when we got the eigenvalue of the matrix A, we go to find about the eigenvector. So eigenvector of A 4, lambda equal to minus 2. So now I just write lambda minus A here. Lambda I minus A is equal to lambda minus 1, 3 minus 3, and minus 3 lambda plus 5 minus 3 minus 6, 6, and lambda minus 4. So this is I write lambda I minus A multiplied by x equal to 0. Now we get lambda equal to minus 2. So is this minus 3, minus 3, 3, minus 3. This one is minus 3. This one is minus 2 is 3. This one is minus 3. And this one is minus 6, 6, and minus 2 is minus 6. x1, x2, and x3 equal to 0. Equal to 0. So I just omit this one. And we convert from this form of the matrix, the H-man matrix, to the form of equation of from the matrix. We convert to the H-man matrix. So H-man matrix we got minus 3, 3, minus 3, and 0, minus 3, 3, minus 3, and 0, minus 6, 6, and minus 6, 0. So I write or 1 over 3, or over minus 3, or 2, minus or 1, or 3, minus 2 or 1. So we get about our H-man matrix 1, minus 1, 1, and 0. This one is 0, 0, 0, and 0. This one also 0, 0, 0, and 0. Row 1, row 2, and row 3 is infinity solution. So we have only the equation 1. Our equation 1 is x1 minus x2 minus plus x3 equal to 0. This is linear equation. This one is linear equation, but one equation have 3 variable or 3 unknown. So we left up to us. We can let x2 equal to t and x3 equal to r, where t and r is belong to real number. So we got x1 is equal to x2 minus x3. So our x2 is t minus r, and x3 is r. Now we get the eigenvector of this matrix. Eigenvector. I just write eigenvector V is equal to x1, x2, and x3. So is this equal to x1 is t minus r, x2 is t, x3 is r. So we separate parameter r and t by part of t and r. So we got t and 0 plus this one minus r, 0 and r. This one is factorize t, this one is factorize r. So we got t is 1, 1 and 0 plus r minus 1, 0 and 1. And now we got V1. Eigenvector V1 is equal to, I can write 1, 1 and 0. And V2 is equal to minus 1, 0 and 1. Is V2. Now we just find the eigenvector for lambda equal to 4. Lambda equal to 4. So I got lambda I minus a equal to I can write about the lambda minus 1 and 4 is 3. 3 minus 3 and 3. 3, 4 plus 5 is 9 and minus 3. This one minus 3. And this one is 6 minus 6. 6 and 0. 4 minus 4 is 0. So I just write only Eichmann matrix. I left out for 2 rows. I just 3 minus 3 and this one is minus 3, yeah. Minus 3. This one is 3. Okay. This one is 3, yeah. 3. 3, 3 minus 3. Minus 3, 9, minus 3. Minus 6, 6 and 0. Okay. And this one is minus 3, 9, and minus 3. 6 minus 6, 6 and 0. The right hand side is 0, 0 and 0. So we just find the I just write O1. O1 is from O1, O2 plus O1 and O3 plus 2O1. So we get this one is 1, 1, minus 1. And this one is 0. This one is 12. This one is minus 6. This one is 0. This one is 12. 12, yeah. And this one is minus 6. Minus 6 is 0 and 0. So now I just write O1 is O1, O2 over 6 and O3 minus O2. So we got this one is 1, 1 minus 1 and 0. This one is 0, 2 minus 1 and 0. This one is 0, 0, 0 and 0. So the equation 3 is infinity solution. So we just write only equation 2 and equation 1. Equation 2, I have 2x2 minus x3 equal to 0. So I left. But this one is coefficient 1, is coefficient 2. So I left the two coefficient. I let x2 equal s. So I got x3 equal to x2. So it's equal to 2s. And x1 plus x2 minus x3 equal to 0. So I have x1 plus x2 plus 2s minus x3 sorry, this one x2 is s, that's s minus 2s equals 0. So we got x1 is equal to this one is s. Now we find the eigenvector. So I just write v3. v3 is equal to x1 is s, x2 s, and x3 is 2s. I factorize about s, I get 1, 1, 2, and this one is s. So v3 is equal to 1, 1, and 2. Now I got the p. P is 110 minus 101 and this one. So modal matrix. I write modal matrix P equal to 1, 110 or 101. Just check again. 110 and minus 101. 110 110 minus 101 and 112. So I just find about p minus 1. P power minus 1 is equal to 1 over determinant P adjoint P, this one, adjoint P. So it's equal to determinant of P. Determinant of P is, I take this one there, plus, I omit this one, and this one. So I got minus 1. Is 0? No need. And I omit this one, and this one. Is 1 minus 1 is 0. 0. And the next. Just take this one and this one, 0 and 1. So it's equal to 2. This one is 2. Is 2. So I got the determinant of P is 2. 2. So I just write this only 1 over 2. And adjoint. Adjoint, I just write the cofactor transposer. The cofactor, we know already how to find the cofactor of this one. So we omit this one and omit this one. It's plus minus 1. So I just write this one is minus 1. Minus 1. And this one is minus. We omit this one and this one. Minus is 2. So is minus 2. This one I just write minus 2. Minus 2. And the next I omit this one. Plus and 1, have only 1. So I just write number 1. Number 1. the row 1 already, we go to row 2. Row 2 and column 1. So we got this one, 2, 1 is minus. Minus 2 and minus is 2. So this one. And the next. Next, I just omit column 2. Column 2, 2, 2 is plus, is 2. So I write 2. 2. And the next column. Column 3 is 1. Column 3 is 2. 2, 3 is minus. Is minus 1. So this is minus 1. So this is we find the cofactor. Now the start to the column 3. Column 3, we just this one, omit this one and this one. So we got 3, 1 is 4 is plus, so it's minus 1. So I just write minus 1. And the next is column 2. Omit column 2. Omit column 2, we got 1 minus 1 is 0. 1 minus 1 is 0. And the column 3. The column 3, we omit this one is 0, is 1. 3 is 3 by 3 is 1 is 1, yeah. Plus is 1. So we got, now we can write p power minus 1 is 1 over 2. 1 over 2, and this one is transposer. We can write minus 1, minus 2, 1. 2, 2, minus 1. Minus 1, 0, and 1. Now we find D. D, just to write P in here. Our D is equal to P power minus 1, A, and P. So I write this one 1 over 2. P power minus 1 minus 1 minus 2 1. 2, 2 minus 1. Minus 1, 0, 1. So now we write A. Our A, the matrix A. This is matrix A. I just write only A. A is 1 minus 3, 3. 3 minus 5, 3. 6 minus 6 and 4. And matrix P. P is 1 minus 1, 1. 1, 0, 1. 0, 1, 2. This one, 0, 1, 2. So now we just find. We can do by our thinking which one multiply and which one is okay for you. So I got D. I just write 1 over 2. And I write this one is -1, -2, 1, 2, 2, -1, -1, 0, and 2, and 1. And this one multiply this one is 3, 1 minus 3 is -2, -1, 0, and 3 is 2, 1 minus 3 is -2, -2 and 6 is 4, 4, and 3 minus 5, 3 minus 5 is -2, -3 and 3 is 0, 3 minus 5 and 6, 1 is 4, 6 and -6 is 0, -6 and 4 is -2, 6 minus 6, this one is 8, this one is 0. So we got D. D is 1 over 2. -2 -2 and -4. This one is 2. 2 minus 4 is -2. This one is -2. Is 2 minus 4 is -2. This one -2 and plus 2 is 0. This one is 4. 4 is 8. This one is 4 minus 4. This one is 4. And this one is 8. Okay, what is this one? Okay, now we just about this one. We have confused this one. I think this one is, when we omit this one, is this one and this one. -2 and -1 is -3. This one is -3. Yeah. Just -3. This one is -3. So this one get to -3. -3. Okay, this one is -3. -3. So I just calculate this one. And about this one is -3. -3. So is it minus this 2 plus 6 is 4. So this one is 4, yeah, not -2. This one is 4. And this one is 2 minus 2 and 2 is 0. This one is -4. -4 and this one is -4. this one is minus 12 and this one is minus 8. So we get this one. I just think about that one. I check this one. So this one is 3, not minus 3, it's 3. 3 is 3 is 3 is 3, 3. So now we just find the next is 3. We just write minus 2 2 2, this one minus 4. This one is minus 4. This 2 minus 2 2, this one minus 4 plus 12. Okay, this 0. Now we just go to this point, minus 4 and 4 is 0. 4 minus 4, 0 and 0, so it is minus 4. And that point is minus 8 and 8 is 0. So this one minus 2 and 2 is 0. And this one is 1, 2 minus 2 is 0. And this one is 4 minus 4 and plus 8 is 8. 8. So we get our diagonal matrix. Our diagonal matrix is D is equal to we can multiply this one or multiply this one is minus 2 0 0 0 minus 2 0 and 0 0 4. This is the diagonal matrix of matrix A. So we can find diagonal matrix by characteristic equation. Now we got the diagonal matrix of the matrix A.